Hey everybody, I am video recording live during period 3, so if you have any questions, please let me know. Just remember this is going up on the YouTube channel, so hit that bell. Okay. Uh, One of my favorite YouTubers says that, so I guess I can too. Today we're talking more graphing rationals, rational functions, and we're going to talk a little bit about how some stuff that we used before is going to intermix, especially when you have something that's cubed. So you could try and divide this out and see if you could get something. But to be honest with you, I think your best place with something that's cubed is to do the plus or minus the constant over the plus or minus the coefficient uh, for your numerator, and then try to factor that out, and then later factor out your denominator. So first off, let's talk about this numerator. Um, my possible zeros could be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, all over plus or minus 1. Okay, the factors of the constant divided by the factors of the coefficient, the lead coefficient. You want to see which ones, when you plug them into the top, will give you 0. So if I plug in a positive 1, I get 1 minus 2, which is negative 1, minus 5, which is negative 6, and then plus 6. So 1 actually works right off. So I'm going to take 1, put it on the outside, and I'm going to use synthetic division to simplify. So now I've got 1, negative 2, negative 5, and 6. So you're going to drop the 1. So I get 1 to negative 1, negative 1, negative 6, negative 6, and 0. So right now I'm looking at my equation being x minus 1. Okay, that's how I get this part here. Times x squared minus x minus 6, which can then be factored into x minus 3 times x plus 2. In my denominator, I'm going to end up with x plus 2 times x plus 1. I'll give you a second to write that down, and if you have a question on anything, let me know. Okay, so the possible zeros, I plugged in 1. 1 ended up giving me a 0, so I can divide that out. And then the x squared minus x minus 6 breaks into x minus 3 times x plus 2. This will set me up for finding holes, vertical asymptotes, horizontal or slant asymptotes, and then last but not least, I'm going to show you today too how to find a possibility of x and y intercepts, because I know that one of your homeworks asks you to do that. It's just a little bit of stuff that I'm going to show you some shortcuts on. All right, so first up, a hole. Okay, if I simplified this out, I would end up with x minus 1 times x minus 3 over x plus 1. So my hole is at negative 2. And then if I plug negative 2 into this equation, I have negative 2 minus 1, so negative 3. Negative 2 minus 3 is negative 5. And negative 2 plus 1 is negative 1, which ends up giving me negative 15. So my hole is at negative 2, negative 15 whenever I'm going to plot. Vertical asymptote. X is equal to negative 1. Horizontal asymptote. None. There should be a slant asymptote. if you look at the degree, okay, I'm going to do this in red. The degree of the highest on top is bigger than the degree of the highest on the bottom. So it's big over small. When I go to do this, I could, use long division and all that kind of stuff, but it might be a little bit of a pain. I can just use the simplified version. The only thing I have to do is factor the top. So x squared minus 4x plus 3 over x plus 1. So that's going to help me find my slant. So 1, negative 4, 3, and negative 1. So synthetic division, 1, negative 1, negative 5, positive 5, 15. I did that right, yeah. So my slant is y is equal to x minus 5. If I don't do something right, call me out. Let me know if I make a mistake. 3 and 5 is 8. See? Thank you. All right. And remember, you're absolutely right. It should have been 8 there. And you know what? It doesn't matter because come on, OneNote. The remainder doesn't matter whenever you're doing it. So it should just be the y is equal to x minus 5. So I'm going to go ahead. I'm going to graph all those asymptotes. I'm going to put them in red. I should have one of them at negative 1. And then I have a slant asymptote, negative 5, going up 1, down 1. Okay. Yeah. When I do the slant, it's negative 4 minus 1, so it should give me negative 5. When I do my slant asymptote, so it's x minus 5, and then the remainder doesn't matter. I'm going to graph. So you can do two different things. First off, I'm going to do what we've been doing in class, the XY chart, all based around the vertical asymptote. I can plug in a point from each of these sides. I can plug in 2 points if I want to. And I can plug them into my shortened, my x minus 1, x minus 3 over x plus 1. So if I plug in negative 2, this is where my hole should be. If I plug in negative 3, I get negative 4 times negative 6 over negative 2, which will give me negative 12. At 0, I'll end up with 3. And by the way, this is my y-intercept. And then if I plug in 1, I get 0 times, is it negative 2 over 2, which will give me 0. This is going to be one of my x-intercepts. So let me go ahead and graph those. So negative 3, 12 is going to be way, way up. And just put this up here somewhere. Negative 3, 12 is going to be somewhere up here. Negative 12, thank you. Sorry. Negative 3, 1, 2, 3. Negative 12, somewhere here. And then we've got negative 2, negative 15, which is going to be clear up here somewhere. That's going to be a hole. You're going to look like you've got a graph that kind of goes something like this. And then at 0, 3, and 1, 0, 0, 3, sorry, 1, 0. you're going to have another something that's going to look kind of like this. Okay. In fact, I'm going to go one better, and I'm going to show you how to find your x-intercept. So this is going to go just a little bit lower. How to find x-intercepts. Y-intercept, you just plug in 0 into your equation. X-intercept's all about your numerator. So, let's see here. I could pull out let's pull out a green color for x-intercepts. X-intercepts are where you factored the numerator. 1, 0, and then 3, 0. What's going to happen is you're going to set your equation equal to 0, and your denominator is going to move over, and it's going to be 0 times whatever that x plus 1 was, so it'll still be 0. So it's all based on your numerator. So if you needed an extra point, you could actually see that your graph is going to go down below here and then come back up and scale. But then that's how the shape of your graph will form. Questions at all? This is one of the more, I feel like, more complicated graphs that you'll see. Okay. So, recap real quick before I move on. What do? Factor. In this case, we had to use our plus or minus our last over our first to find possible zeros. Then once we have everything factored, we can find out where our hole is, if we have one, where our vertical asymptote is, whether we have a horizontal or a slant. And then, to be honest, just use the XY chart, plugging 2 points on one side, 1 or 2 points on one side, 1 or 2 points on the other, and you should be able to find out where your graph is going to be situated around that. Yeah, question? Yes. We did in the other problems. You take all you're doing with this, your hole was near your asymptote. So you actually saw it on your XY. In the previous problems that we've done in class, a lot of it is just you plug it back into the equation. So every time that you get your hole, if you want to find out where your y value is, you plug it back into your simplified equation, and that'll give you that y. It'll give you that coordinate point essentially. All right, we're going to skip 5. 5 right here, I'll talk more about this at a different time. It's just a little bit more practice. It talks about how you can actually cross the horizontal. We're going to go to numbers 6, 7, and 8. I already have these filled out because honestly the answers might vary. But I just want to show you how you can write a rational function with the given asymptotes and holes. So let's take a look at number 6 here. When it says x is equal to, that's automatically a vertical asymptote. When it says y is equal to, unless it says like x plus, like it makes a linear equation, it's going to be a horizontal asymptote. So in order to make these into asymptotes, the first thing is if it's x is equal to 2, in your denominator, this would be x minus 2 as a factor, which is how you end up with the x minus 2 in your denominator down below. To make a horizontal asymptote that's not 0, remember the exponent on top has to be the same as the exponent on bottom. So we would use the lead coefficient. So lead coefficient has to be a 3 over 1. And since the exponent has to be the same on top and bottom, we can just include an x with our 3 to create our equation. So there's how you would simplify number 6. If for some reason you had a horizontal asymptote of 2, like I showed here, like it'd be 2 over 1 out front essentially. You don't have to write any of that down. And that was just showing an extra example. All right, so again, x equals vertical asymptote, y is equal to horizontal asymptote. So take a look at what happens when you add a whole into the equation. So we've got vertical asymptote at x minus 1, x plus 1. So we would have x minus 1 and x plus 1 down in our denominator. It says you have a whole at 1.5, which is 3 over 2. Or I'm sorry, a horizontal asymptote at 3 over 2. So you'd have 3 over 2 or 1.5. And then a whole where x is equal to 0, so we would cancel out. The way that I would first start situating this type of problem is I would say y is equal to, I would look, okay, vertical asymptote, x minus 1, x plus 1, check. My horizontal is 1.5, so I have to have a 3 over 2 out front. And because this is 2 x's on bottom, I need this to be at least an x squared on top. That way they have the same exponent, top and bottom. Because this is really, at this point right now, this is really 3x squared over 2 times x squared minus 1. Last, because I need to cancel out when it's x is equal to 0, I would have to include another x on top and bottom. So now this becomes 3x cubed over 2x times x minus 1 times x plus 1. And then if you needed to, you could simplify your bottom and you would get an x cubed. In fact, I can do that for you right now to kind of show you. This would be 3x cubed. This would be 2x, x squared minus 1, which then becomes 3x cubed, 2x cubed minus 2x. You get a whole of 0 because x divided by x, those would cancel out, and you couldn't have 0 in your denominator there whenever you went to solve. So like if you plugged in a 0 into your equation, it would literally create 0 in your denominator, which would mean that you would have that whole at 0. X cubed in x, that cancels out and it gives you x squared on top, and then it gives you nothing on the bottom there. You would need that in your original equation, though, to show that you had a whole later on. Yep.
So you're trying to add x's where the denominator will equal 0.
You want to add x's so you have something that's going to bring your denominator to 0, and then also you want to include another x because you want the horizontal asymptote to be 3 over 2, so the degree on top and the degree on bottom have to. In order for it to be 3 over 2, it has to be the same on top and the same on bottom. So it's the Lie yes, because it's the Lie coefficient. Yeah. So if you look at something like this, for example, and you know what, I'll erase all this real quick, kind of go through it with you. This says when a whole when x is equal to 0, that's the same as saying that you have x over x, because you have something that can cancel out. Then it says a vertical asymptote. So that would be if x is equal to 2, your factor would be x minus 2. So you'd have x minus 2 in your denominator. That's how in the previous problem, when we put that into 0, you had to put the x over x.